Hello everyone, it's Mike Levin. Thursday, August 18th at about 7:30 a.m. and yeah, I am heading out pretty early. I am currently listening, my latest audiobook is Thinking Fast and Slow. After it came up no less than 2 times as recommendations at the end of the podcasts I'm listening to. So I'm expanding my podcast listening practices because I'm really caught up on my favorite Python podcasts. I have a little backlog still to do of podcast init, but I'm also discovering that Ruby Rogues, sort of a panel format podcast, is the inspiration for a lot of the other programming and coding and data science related podcasts. A lot of these things, I guess the way has been cleared, a format has been suggested, the viability has been proven, and so now a whole bunch more popped up onto the scene in, say, the JavaScript world. I forget what those are exactly. They have a clever name for theirs as well. And then the Python ones that I've been talking about. And at the end of these podcasts, they tend to give their suggestions, stuff they've been, either reading on the net, packages that, they've been working with, books they've been reading, music. It can be anything. And a couple of times, Thinking Fast and Slow has come up. And I wasn't sure, but I thought I had heard in the past association between that book and the concept of getting into the zone or the flow that I do talk about a lot. I think I'll take a slightly different route just for scenery's sake since I'm running so early. And so I got it on Audible format. I returned to my Richard Feynman lecture series, which I finished out with the double slit experiment again in quantum behavior. That seems to be the consistent introduction to quantum physics, to force you to see the particle wave paradoxical state of reality. Nothing less than the fact that things exist as clouds of probability, and the process of observing, or in other words interacting with them in any way, collapses the probability cloud into an actual physical state, and parallels with the real world left and right. I mean, you can tell that there's an object model of reality sort of coming into existence, where the rules and the APIs and the boundaries and interaction properties are all being defined, of all this stuff that can connect together and lump into pieces, which in our world is physical things, and in the programming world is code, programs running in memory, and things can be moved around, and there's metaphors for things. I tend to explain the programming question of by reference or by value when you copy or you move stuff around, and I explain it in terms of Star Trek transporters. If you're sending the actual atoms, you are, I guess, making a copy but destroying the original. If you're popping through a wormhole, you're just changing a pointer to where these atoms are located in three-dimensional space. Probably through a four-dimensional route, which takes the form of some sort of wormhole or portal that things can just pop through. So a lot of these ideas of how the world works defines what's possible. What's possible, the boundaries of reality, such as it were. And there's a lot of talk about holograms and virtual machines, and that we are all just, the virtual machine running in this physical reality. But, for lack of anything else better, the virtual reality is the real reality. Well, you find virtual machines, the ability to run one world inside another, everywhere. Java has very much popularized it with the JRE, the Java Runtime Engine, and talks about it as if they invented it, but virtual machines in the compiling process has been enabling all kinds of magic for a long time. One might argue that the proliferation of the Unix operating system was because of a positive feedback loop that was specifically because once you ported, say, a compiler, then came the operating system, then came the programming language and environment, from which came, you know, compilers for other hardware, doing the cross-compiling trick. So you can compile something for that hardware on this hardware over here that you already have running, move that that compiled image over, say, of an operating system onto that hardware, bam, you've got a working operating system on that hardware. So there's actually a close relationship between the virtual machine and real hardware. A virtual machine is simulating something that could be represented in real physical hardware. In our world, it's integrated circuits, but all that stuff could easily be represented as machines with any mechanical potential. Water going down canals, ball bearings going down little channels. And so you set up the number of things these, you know, mechanical potentials can do, and you call that the machine instruction set. That machine instruction set can be carried out directly by the hardware that was actually laid out on the circuit board around the intent of executing these specific instructions. Things like, you know, the basic building blocks of logic. You know, you go from a simple transistor on-off gate to an OR gate, for example, an AND, and exclusive OR and all that. And then from there you go to a half adder. And from a half adder you go to, you know, full-blown, you know, processors. And you add some memory of two different types in, you know, CPU or processor accessible memory, which is your program running space, so that things can be moved around in memory in this giant X by Y grid, turning bits on and off inside of there, representing different things. And so when you copy something, you take the pattern of bits from over here and you put another set of those bits over here, and now twice the amount of memory of the original object is being used. And that's with a copy. But if you move stuff around by reference, you just take a pointer and you say, when you look here, get your data from over here, and then it reads it from over there. And so that's by reference versus copying an object. And it's an issue that comes up all the time in programming languages. And to really understand some of the differences with Python, and bringing it back to this book I'm reading, Thinking Fast and Slow, Python tends to prefer doing things in the way that it expects most people to want to do a thing. It actually makes a lot of guesses, and it has an extremely simplified API, which includes such things as tearing out all the extra visual white noise, of which other program languages include a lot for some reason, like a curly bracket. That actually adds work, and it forces your thinking mind. System 2 is what the book refers to as your higher level frontal cortex thinking mind, from System 1, which is more like your deeper animal automatic brain that learns things and makes decisions based on assumptions of things it encountered in the past. Well, Python is a programming language that does precisely that, and it fades into the background, becoming something of a muscle memory, a automatic response system. So you actually stop having to think so much. Okay, so the bringing it all back home, the righteous feedback loop. Never before, in my opinion, has a programming language simultaneously reduced the stress and the work of thinking in code so effectively, and brought so many additional building blocks applicable to all sorts of problems all into play at the same time. Python is doing something. Oh, and plenty of varied user interfaces for interacting with it for different advantages based on the runtime type that you want. So Python is just rife full of all these opinions, rules for running the universe. It is a virtual machine, such as almost everything else in tech. It's riddled with virtual machines. The Java runtime engine, the JRE, didn't invent it. Every programming language that has dynamic features is trying to stick a virtual machine in the process so that you write the code for the machine and the machine can make dynamic decisions on the fly while the program is running without being bound to the specific piece of outer hardware. And it helps with porting your software. Arguably, it helps with execution time because it has certain internal optimizations for that particular virtual machine. So Python is a virtual machine. I believe Ruby has gotten there where their runtime engine is a virtual machine. And it's all the frig over the place. That Linux thing that I put out is to get certain particular VM advantages. And so Python is a simulated reality. It's a little world that you get natural at thinking in, and then you think in terms of tuples and lists and dictionaries and all their variations, subclassing them, understanding that other things that are available to you are subclassed instances of them, or are subclasses of them, like the named dict or the ordered dictionary. It's named tuple and ordered dict. Those are two great examples of how the world, the little programming world, is so much more rich just because of a few extra rules of reality thrown in. And now you can express, you can talk, you can write for the virtual machine more eloquently with shorter, more clear, easy to understand language. And if done early enough, bringing it back to daughter's education, if done early enough, the introduction of Python as if it were no different than spoken language, playing down the coding difficulties part of it and playing up the encoding and decoding similarities to the spoken and written language, just encoding thoughts and expressing yourselves. That happens to be, hey Spider, how you doing? That just happens to be an automation language for machines, and anything machines can interact with, which is a very big array of things these days, of course. And so there you have it, fallen in love with Python. It's a sort of virtual reality, virtual world, virtual machine that you get very comfortable at delving down and thinking in and constructing things very fast, as if you're the architect in what was that movie that had the architect? Is it the Matrix, maybe? Anyway, like you're the architect, whoosh, flying things together, snapping them up together as rapidly as you can think that idea to express yourself. Therefore, the gap between ideation and expression and implementation gets smaller and smaller and smaller, and you have what is, the equivalent in the information age of superpowers. That's sort of what I'm going after. Stick with me, subscribe, and jump on the Python bandwagon through my particular, very rough, non-edited, perpetual noob and perpetual beginner, even though I'm a little advanced in some ways, just because I've been doing this for so long on other languages and platforms. So there you have it. I'm going to wrap up there, get to work. Thanks for joining me. Hope to see you again soon, and don't forget to subscribe.